Okay, I think I'm recording my video. Let's see if I can find it. Yeah, it's on live now, but the problem is I need to bring my handout and do other things, so please wait a couple of minutes, okay? Right. Did you guys bring the handout that I gave you last time?
No.
No, okay.
他什么时候给我们看到？上学期吗？
没有，所以他就说问我们说没有，老韩说没有了，有的丢害掉了。
有也得说没有。
就是啊，凭什么有啊？
我不记得他给我们看到啊。上学期的事吧。
上学期也没有啊，上学期末的时候他就什么也没干。
Okay, I asked to bring the handout to my TA. So basically, I'm teaching here and also using my laptop. I'm just doing the YouTube live on this class. So some students in China, I think they will never watch it, but in theory, they can watch it at the same time. That is the recommendation of the Ministry of Education. Okay? So basically, I will teach as much as possible, and it will be very intensive class. So we will do something about OLS, and I hope you guys remember what I said in OLS. This one is too far. Let's make it a little bit more close. Can they see? Maybe slightly better, but it is still very unvisible. But anyway, we will solve it, and I think nobody will watch it. They will watch it probably 5 minutes and say that I watched it, but they never studied it. That's the typical, the student behavior. So not a problem. But anyway, so we are talking about the OLS, and what I taught was something like the mathematical version of OLS. And in my last class, what I taught was something about matrix. So in case of mathematical version, OLS is pretty long. There are a lot of derivations, too many mathematical operations. But in case of OLS in matrix version, it is relatively simple. And usually people use mathematics, they like this kind of simplistic version. That's why we are using the matrix version of OLS. And to understand the matrix version of OLS, you need to understand what the matrix is. So what I taught about in my last class was the basic theory of matrix. So in case of matrix, what we can see is something like y1 equals alpha plus beta x1 plus epsilon 1, something like this. This is the first observation. Second observation is y2 equals alpha plus beta x2 plus epsilon 2. The third observation is y3 equals alpha plus beta x3 plus epsilon 3. In this case, we have 3 observations and 3 equations. In case of the mathematical version, we have 3 equations. In case of OLS version, basically this is just one example. In general, when we do data analysis, we have 100 observations or more. Okay? Y4, Y5, Y6, Y7, Y8, 100 observations. If you write down in terms of matrix version, it takes too much space. The mathematical version takes too much space, so people generally prefer matrix version. In this matrix version, we change it into matrix. That is something like y1, y2, y3. This is 3 by 1 matrix. Then this is the same as this one. Alpha plus beta x1 plus epsilon 1, alpha plus beta x2 plus epsilon 2, alpha plus beta x3 plus epsilon 3. This is 3 by 1 matrix, 3 rows, number of rows, 1 column. Okay? 1 matrix, 3 rows and 1 column, 3 by 1 matrix. This is also 3 by 1 matrix. 1, 2, 3 row and 1 column. Okay? Question? Then this one can be divided into 2 things. One is alpha plus beta x1, alpha plus beta x2, alpha plus beta x3, plus epsilon 1, epsilon 2, epsilon 3. This one is also 3 by 1 matrix. This is also 3 by 1 matrix. Okay? So previously it was 1 column and 1 matrix. Matrix is addable. You can add 2 matrices if the rank 3 by 1, 3 by 1 is the same. For example, when you have 1, 2, 3 plus 1, 1, 2, this one becomes 2, 3, 5. Just like this. Okay? 3 by 1 matrix, 3 by 1 matrix, 3 by 1 matrix, you can add them. Okay? What I did here is from here to here, the other direction. Okay? This part and this part, they were added. Now I separated them. Okay? So 1 column, then this part is this one, this part is this one. Okay? Matrix is addable. Yeah, additive. Incorrect English, I guess. But anyway, this way. Then there's one more thing. This one and this one, what is more complicated is matrix multiplication. Okay? I think you guys forget completely about matrix multiplication. So this is 3 by 1 matrix. Then how do we make this kind of thing? Here, what we have is 1. Let me write it in a different way. Alpha plus beta x1 is the same as 1 times alpha plus x1 times beta. Okay? Alpha plus beta x2 in the same way, 1 times alpha plus x2 times beta. Okay? The third one is alpha plus beta x3, 1 times alpha plus x3 times beta. All of them, they have the same structure. 1, 1, 1, alpha, 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 beta, beta, beta. What changes is x1, x2, and x3. Okay? So this is the data generating structure. We have the first observation, second observation, the third observation. This one is 1 times alpha. This one is 1 times beta, 1 times alpha, 1 times alpha. And beta is the same for first observation, second observation, third observation. It's changing. And then first error term, second error term, the third error term. That is the structure of OLS. We have data generating process, yi equals alpha plus beta xi plus epsilon I. Okay? This is example, this is data generating process. This is a general form. But this one can be written as 1, 1, 1, alpha, 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 x1, x2, x3, and beta, beta, beta. This can be written as matrix multiplication. And do you guys remember what is matrix multiplication? So I will teach it again. So in case matrix multiplication, the first one is 1, 2, 3, and what you multiply is scalar multiplication. Okay? You can simply multiply number 3 here. Okay? So this is 3 by 1 matrix, and this is 1 by 1 matrix. 1 row, 1 column. Okay? 3 rows, 1 column. This kind of scalar, this kind of one number is called a scalar in matrix theory. Scalar multiplication is the same. You simply multiply this number to here, this number to here, and this number to here. So the answer is 3, 6, 9. Relatively simple. Okay? When you do something the same, 1, 2, 3, this is pre-multiplication, this is post-multiplication. But anyway, the result is the same. 3, 6, 9. Okay? This is one thing. Another thing is matrix multiplication. A little bit more complicated. Okay? In this case, what you have is something like this. Let me change it. 1, 2. This is 2 by 1 matrix. Okay? Then we can multiply 2 here. Post multiplication. That is relatively simple. Okay? But the problem is, what if I have some number like this? Then this is 1 by 2 matrix. Okay? Do you guys remember this kind of thing? Then what matters is this number and this number, they need to match. Okay? And this one becomes the result of matrix multiplication. Okay? So now forget about this part. When you do not have this part, what is the result?
2, 4.
2, 4. That's simple. I just truth it.
Yeah.
Okay? So the first result is 2 and 4. Okay? If you think you don't have this part, what is the result?
3, 0, and 6.
3 and 6. This is matrix multiplication. Okay? So when you see this one all together, it looks very complicated. But this is some kind of definition of matrix. Is it keep recording? I guess so. The basic thing is, when you do this kind of post multiplication, it becomes 369. Okay? So this is one post multiplication. The result is the first row. Okay? This is the second post multiplication. The result is the second row. How many rows does it have? 1, 2. How many columns does it have? Okay? This number, this is 2 by 1 matrix. This is 1 by 2 matrix. Okay? Then this one is 2 by 2 matrix. 2 by 2 matrix. But this is not a general case. Okay? But anyway, this is how we do matrix multiplication. First one, multiply it, first row. Second one, multiply it, second row. Okay? Then there is another case. In this one, when you simply reverse it, this way, what is the result? This is 1 by 2 matrix. Okay? And this is 2 by 1 matrix. 1 row, 2 columns. 2 rows, 1 column. This number and this number, they match. The result is 1 by 1 matrix. 1 by 1 matrix is scalar. Okay? Then how do we calculate this one? If you remember, this one and this one, the result is 2 times 1, this one times this one, plus 3 times 2. This is the result. Okay? Then, what is the result? 2 plus 6, that is 8. Okay? So this is the first way of matrix multiplication. This is the second way of matrix multiplication. You need to remember both of them. Okay? So in this way, this one is something called scalar multiplication of matrix. But anyway, the result is when you have something like this, 1 row and 2 columns, and 2 rows and 1 column. What you do is this one times this one plus this one times this one and add them up. Okay? Here, what you see is something similar. What we need is alpha 1 times alpha plus beta times x1 times, how did I write? Doesn't matter. Yeah. X1 times beta, let me write it down in this way. Okay? Then this is the same as 1 times x1 alpha beta. Okay? Then this is 1 by 2 matrix. This is 2 by 1 matrix. Okay? Then how do we multiply it? 1 times alpha, 1 times alpha plus x1 times beta, this way, that is alpha plus x1 beta, which is the same as this one. Okay? So this is the matrix multiplication. In other words, you can write this one into this way. Okay? They are the same when you use matrix multiplication. That's why you guys are learning this matrix multiplication. This one can be written as this one. It is divided in this way. This one, by using matrix multiplication, you can write it down in this way. Okay? Then you need to learn something more. Let's do something else. Then what you have is something like 2, 3, 2, 3, 1, 2, and 1, 2. Okay? Now it is slightly different, but advanced version. Now this is 2 by 2 matrix. This one is 2 by 1 matrix. This number 2 and this number 2, they match. The result is 2 by 1 matrix. Okay? How do you do this? When you forget about this part, okay? This is the same as this one. Okay? So the first result is 2 times 1 plus 3 times 2. This way. Okay? When you forget about this part, anyway, you can also do this. But this is from the second row, so let's write it down the result in the second row. Okay? So 1 times 1 plus 2 times 2. Okay? The result is 2 plus 6, 1 plus 5, 8 plus 6. 2 by 1 matrix. 2 rows, 1 column. 2 by 2, 2 by 1, the result is 2 by 1, this one.
Sorry, the second row should be 1 plus 4, right? It's
sorry?
not 1 plus 5, it's 1
yeah, 1
plus
plus
4.
4. You are
Yeah.
correct. Good job. You are paying attention. I like that kind of attention. Okay, this way. Okay, so this is the result. This is the basic of matrix multiplication. Okay, then this one can be applied to here as well. This way. Okay, the first row and first column, 2 by 2 matrix, 2 by 1 matrix. The result is 2 by 1 matrix. How do we do this kind of matrix multiplication? 1 times alpha plus x1 times beta. Okay? This one times this one plus this one times this one. Okay? Then, when you forget about this part, 1 times alpha plus x2 times beta. Okay? Then, this is the alpha plus beta x1, alpha plus beta x2. This way. Okay? Then what is the next step? Yeah. For our purpose, let's make it simple. 0 and 1 this way. Okay? Now you have 3 rows and
2 columns.
2 columns. 2 rows and 1 column. This number 2 and this number 2, they are the same. The result will be 3 by 1. Okay? Then, if I do it quickly, oh, I should have not deleted it. But 2 times 1 plus 3 times 2. 1 times 1 plus 2 times 2. 0 times 1 plus 1 times 2. Okay? Then the result will be 2 plus 6, 1 plus 4, 0 plus 2, 8, 5, 2. Okay? This one is 3 by 1 matrix. You need to practice this one again and again and again. Then finally, you will run this kind of thing. But in case of matrix, there's no way that you can avoid this one. And if you are trying to run data analysis, there's no way you can avoid this kind of matrix theory. So go back to your home and practice. Okay? Search about matrix multiplication in YouTube. Then Chinese teachers will teach matrix multiplication in Chinese. But anyway, you need some practice. Okay? If I do this kind of thing quickly, okay? Now, you may see some kind of rule here. You will see, for the second one, you will see 1 x3 and alpha and beta, you will finally get this one. Okay? So in terms of matrix theory, this is the same as this matrix can be divided this one and this one plus epsilon 1, epsilon 2, epsilon 3. This way. Okay? This one will be divided into these 2 ways. Okay? That's why we run matrix in OLS. When you have 100 observations, you need to write down this equation 100 times. But in the simplest way, basically what we write down as matrix theory is something like this. They are the same. Let me write it down this way. 1x1, 1x2, 1x3, alpha and beta, plus epsilon 1, epsilon 2, epsilon 3. It really doesn't matter. In this case, you have 3 observations, but when you have 100 observations, you have 100 rows and 1 column. Okay? So we write it down as Y matrix. Okay? 3 by 1 matrix. Y matrix, this is in general we call X matrix. Okay? This X matrix, 3 rows and 2 columns. This one, we call it as B matrix. This one is 2 rows and 1 column. Okay? And then this matrix is called as E matrix. 3 by 1. Okay? When you have 100 observations, you can simply change this 100, 100, 100. So in general, we write it down n by 1, n by 2, n by 1. Okay? This is matrix version of OLS. Instead of writing 100 rows, simply writing it down in this one simple way by using matrix multiplication. Okay? So I gave you the handout. The first one is that OLS matrix. You remember that my long handout in the past, but when you use matrix, it is only 2 pages long. So as I remember, all the students, they can memorize this 2-page handout very simply. But many students, when they do not study, they have no idea what this means. Because this is short enough, they can write it down in the final exam without knowing the meaning. But that is not recommended. Okay? So try to understand this matrix theory. So this is the first part. There are some kind of data generating process, that is y equals xb plus e. Okay? Okay? Then by using this matrix theory, I can teach something. But you need to learn some more matrix theory to understand this kind of things. Okay? Then let me teach some more matrix theory. Then the next part, we run this kind of thing. The second one is what happens when we have 1, 2, 3, 4. I taught something like this one, 1, 2. This way, okay? What happens when you have one more row? Okay? This is general matrix multiplication form, okay? 2 by 2 matrix and 2 by 2 matrix. This number and this number is the same. The result will be 2 by 2. Okay? When you forget about this one, what is the result? 1 times 1 plus 2 times 2. This one times this one plus this one times this one. Okay? And what is this one? 3 times 1 plus 4 times 2. Okay? Question? Then, when you forget about this one, what is the way of calculation? 1 times 0 plus 2 times 1. Okay? Forget about this one. 3 times 0 plus 4 times 1. Okay? So usually when I do this kind of multiplication, I make like this. Do this one times this one here. This one times this one here. Add them up. This one becomes one element. Then this one times this one times this one, second element. This one times this one, third element, and this one times this one, the fourth element. Okay? The result is 1 plus 4, 0 plus 2, 3 plus 8, 0 plus 4. 5, 2, 11, 4. 2 by 2 matrix. Okay? So if you understand the Bayesian matrix multiplication, this is the result of it. Final result. Basically, this one is scalar multiplication of vectors. First row, first column, one vector, another vector, they will become one number, scalar. First vector and second row, first column, they will become one scalar. Okay? So that is how we define matrix multiplication. Okay? So this one is the same as you have this one, okay? And then this one. And then this one. And then this one. Okay? 4 operations. We write down this kind of 4 operations together, calculate them, each of them, and then get the number. So, practice. Practice and practice and practice. Matrix multiplication, it looks very simple, but if you understand it, it will make your life simple. If you don't understand it, then forget about data analysis forever. Okay? You can do the data analysis, you will get the result, you will claim that you know something about that, but actually you know nothing about that. Just interpret the result. I don't recommend it. The reason that you do not understand the background theory of all those kind of data analysis, because when you see this kind of matrix multiplication, you think, oh, it's complicated. I don't like it. It must be not that important. Let's move to the next step. Then, when in the next step, oh, I have no idea about matrix multiplication. Oh, data analysis is too difficult for me. Okay, why don't I just ask somebody who knows about it, give him the data, make him the analysis, just get the result and use it. I don't recommend it. Okay? So, do this kind of matrix multiplication, practice, 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 watch some YouTube video by Chinese teachers. Anyway, indeed, it is not that complicated. Okay? First row, first column, multiply them, write it down here. Second row, first column, multiply it, write it here. Second row, first column. Okay? First row, second column, multiply them, write it here. First row, second column. Okay? The only difference is this one times this one plus this one times this one. Okay? That is the definition of matrix multiplication. If you practice about a week, you can do it. I think so. This a week of multiplication, well, probably just 7 hours. 1 hour for 7 days. You can do it. But when you are rich enough, you will never do this kind of thing. Then forget about data analysis. I don't recommend it. Okay? So this is the basic matrix multiplication. Question? So practice, practice, and practice. I gave you the second handout about basic matrix multiplication. I gave this kind of handout last semester. Okay? I asked you to study about it, and I think you didn't study. So please study this time. It is talking about the same thing. Okay? Then the next one is matrix inverse. The reason that we use this kind of matrix theory is mainly because it is very convenient for solving a system of equations. So you can think about this kind of matrix theory. X plus y equals 2, and 2 2x plus y equals 3, something like this. Two equations and two unknowns. Okay? You have two equations, equation number 1, equation number 2. Two unknowns, that is x and y. Okay? When the number of equations and when the number of unknowns are the same, you can solve this system of equations. There are so many ways of solving the system of equations. The simplest version is matrix. That's why people use matrix theory so many times. When you have only two equations and two unknowns, you can do it by hand. Then how about when you have 100 equations and 100 unknowns? Of course, you can solve it by hand in your typical way. It's possible, but it will take too much time. In case of matrix, it's still one line. That is why people use this kind of matrix theory. Okay? So in this case, when I write down this one in a matrix form, what you have is x plus y, 2x plus y equals 2 and 3. Okay? This is 2 by 1 matrix. This is also 2 by 1 matrix. Okay? 2 rows and 1 column. The best part of matrix is you can write it down into another matrix. 1, 1, 2, 1, x and y. This is 2 by 2 matrix. This is 2 by 1 matrix. This number 2 and this number 2, they match. Then the result is 2 by 1, 2 by 1. Okay? Then 1 times x, that is x, plus 1 times y, that is y. Okay? 2 times x, that is 2x. 1 times y, that is y. Okay? If I write down in this way, this one is the simple version, something like this. Okay? So in this way, 1 times x, x, plus 1 times y, y. 2 times x, 2x, plus 1 times y, this way. If you don't understand it, practice. Okay? Here to here and here to here, it is very frequently used. Okay? Then, in this way, this is 2 by 2 matrix, this is 1 by 2 matrix. Okay? Then, we can solve this matrix. When you have 100 equations, you will get something like 100 by 100 matrix, 100, 2 by 1 matrix. 100 by 1 matrix, 100 by 1 matrix. Okay? And then, to solve this system of equations, we use something called matrix inverse. Who is looking for me? Okay? Then what is matrix inverse? This is solving the system of equations. Here, what we want is, what is that? The value of two unknowns. Okay? we have two equations, and then these two unknowns, x and y, they solve these two equations at the same time. Okay? So that is the purpose of this kind of solving a system of equations. Okay? Then what is the meaning in terms of geometry? Okay? In terms of geometry, we have something like this. This is y-axis, this is x-axis. We can write it down in this way. Y equals minus x plus 2. Moving this one, this way. Question? Y equals negative 2x plus 3. Moving this one to this way. Okay? Then when I draw a graph of this one, okay, the graph is y equals 2 and minus x. This is the graph. Okay? Y equals minus x plus 2. Intercept is 2. Slope is negative 1. Okay? Then how about this one? This one is y equals 3, intercept is 3, slope is negative 2, it will become something like this. Okay? This is y equals negative 2x plus 3. This way. Then here is one crossing point. Okay? This is one line, this is another line. This line represents this equation. Another line represents this equation. Okay? They cross only at one point. Okay? This point is the solution of this system of equations. In this case, the crossing point is 1 and 1. When x equals 1 and y equals 1, x plus y equals 2, it satisfies the first equation. When x equals 1, y equals 1, 2 plus 1, that's 3, it satisfies the second equation. Okay? So, x equals 1 and y equals 1, these 2 points, it satisfies this equation and this equation simultaneously or together. At the same time, these values, it solves this equation and this equation. Okay? So this is called as solving a system of equations. Two equations, because it is 2 or 3, 4, 5, 6, many equations, it is system of equations. Solving it means that this value satisfies first equation and second equation together. Okay? In terms of geometry, you have one line, another line. Here is one crossing point. This crossing point satisfies first equation, second equation at the same time. Okay? So this is the meaning of solving a system of equations. Okay? Why we use matrix? Because by using matrix inverse, we can solve a system of equations. Here, in solving a system of equations, what we need is the value of x and y. Okay? Then here, we have system of equation. We write it down in terms of matrix form. Okay? Then I rewrite it in this way. Okay? Then the next step is matrix inverse. 1, 1, 2, 1. Inverse. 1, 1, 2, 1. X and Y. 1, 1, 2, 1. Inverse. 2 and 3. This is the matrix that I have. Okay? This is inverse matrix. Okay? One matrix multiply inverse matrix, you can make it an identity matrix. Because I multiplied inverse matrix here, I need to multiply another inverse matrix here. Okay? One inverse matrix here, another inverse matrix here. Okay? That is the concept. Then the result will be the solution of a system of equations. Then what is the result? Yeah. So let me write down the concept of inverse in a different way. In case of scalar case, you have something like 2x equals 2. Okay? Then how do you solve this one? There are so many ways, but one way is multiply in both sides. Okay? So when you want to solve this one, you multiply the inverse of 2. That is this one, both sides. Okay? Then you cancel out this number. Okay? 1 times x equals 1. This means that the value of x equals, okay? In other words, by multiplying inverse of this number, okay? Inverse of this number, both sides, you can solve this equation. In case of matrix, the concept is the same. You have some matrix, multiply inverse matrix here and here. You can solve the value of this x and y together. Okay? So system of equations, you need to satisfy these two equations together at the same time. Okay? So that is the concept of inverse matrix. In case of scalar, you are right around it. Multiply the inverse of this number, both sides, then you will get the value of x. When you have two equations together, you need to use matrix inverse. Okay? So in case of matrix inverse, you have something like A and B and C and D. This one. Do you remember what is the inverse of this one? You guys didn't study at all. AD minus BC, DA minus B minus C. This is the inverse matrix. You need to memorize this. In case of 2 by 2 case. Okay? It is not that simple, not that complicated. So when you have A and B and C, D, then what you need is something like A times D minus B times C. Okay? This number is called as determinant. Okay? Something called determinant, and A and D, they change their positions. Indeed, what we do is delete the first row and second row. First row and first column, this D remains here. And delete second row and second column, and then A remains here. That is real mathematical operation, but for simple memorization, A and D, they change their position. Okay? And then B and C, we need to multiply negative sign here. Okay? That is matrix inverse. Please memorize this. There's no way that you can avoid this matrix inverse in solving system of equations. It is also not unbelievably complicated. If you spend about an hour, you can memorize this one. Okay? So practice, practice, practice. Watch the YouTube by Chinese teachers talking about matrix inverse. Memorize it. Then what we have is here, this one. Okay? Then we have 1, 1, 2, 1. This is our matrix. What we need to calculate is matrix inverse. Okay? Then how do we calculate it? AD, this one times this one, 1 times 1, minus BC, 1 times 2. Okay? This part becomes determinant. 1 minus 2, our determinant is negative 1. Okay? That's the concept. This one, A and D, they change their positions, but it's still the same. 1 and 1. Okay? And 1 and 2, we need to multiply negative 1, negative 2. Okay? Then what you have is 1 divided by negative 1, 1, negative 1, negative 2, 1. This is number negative 1 times 1, negative 1, negative 2, 1. This way. This is a scalar. This is matrix. Then scalar times matrix, we multiply this number 2 here, 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 here at the same time. Okay? Then what you get is negative 1, 1, 2, negative 1. This way. Okay? This is our inverse matrix. Then what we need to calculate is this part. Okay? We multiply inverse matrix in front of this matrix. Then when we do this kind of calculation, let me use this one here. Negative 1, 1, 2, negative 1, multiply 1, 1, 2, 1. Okay? This is our original matrix. This is our inverse matrix. Okay? Then when you multiply this one, you will see something interesting. Negative 1 times 1 plus 1 times 2. Okay? Negative 1 times 1, negative 1 times 1 plus 1 times 1. Second one, 2 times 2, I'm sorry, 2 times 1 plus negative 1 times 2. 2 times 2, 2 times 1, negative 1 times 1. Okay? The result is negative 1 plus 2, negative 1 plus 1, 2, negative 2, 2 minus 1. The result is 1, 0, 0, 1. Okay? Always, all the time, when the inverse matrix exists. Okay? When I told you I think 2x equals 2. This is the example. When you multiply inverse of it, the number that you got here is 1. Okay? You will make this part 1. In case of matrix, we make this diagonal part 1 and 1. This matrix is called identity matrix. Okay? I think the only thing that I can delete is this part. So in this case of identity matrix, this one is 1, 0, 0, 1 in case of 2 by 2 matrix. Okay? Then when you use this one, we usually write it identity in this way. When you have this kind of matrix, when you multiply x and y here, this is 2 by 1. Okay? What is the result? 1 times x plus 0 times y. Okay? Second one is 0 times x plus 1 times y. Okay? What is the result? X plus 0, 0 plus y, x and y. Okay? Identity matrix times something, you will get the same matrix. That is the characteristics of identity matrix. In case of scalar version, 1 times 6, what is the result? 6. That is the property of 1. Okay? If you multiply 1 to something, you will get the same number. In case of matrix, when you multiply identity matrix into another matrix, you will get the same matrix. You see this one. Basically, 1 times x plus 0 times y kill y. Okay? 1 times x plus 1 times 0 times x plus 1 times y kill x. Then only x and y remains. You will get the original matrix. Okay? That is the result. So this is the property of identity matrix. This is our original matrix. Okay? This is our inverse matrix. Original matrix times inverse matrix, you will get identity matrix 1, 0, 0, 1. This way, okay? Identity matrix times some new matrix, you will get the matrix again. Okay? Then now we can solve. I think I can delete this kind of determinant. This system of equations. If I keep solving this part, this is our original matrix, this is our identity matrix, okay? Inverse matrix, I'm sorry. Then original matrix times identity matrix, you will get inverse matrix. I'm sorry, identity matrix, yes. Original matrix, inverse matrix, when you multiply them, you will get identity matrix. Yeah, okay? So what you have here is 1, 0, 0, 1 times x and y equals this part I calculated over here. Oh, I just deleted it. Yeah, this is our identity matrix, this part. Okay? This part is our identity matrix. Inverse matrix. Okay? So, negative 1, 1, 2, negative 1, and 2 and 3. Okay? Identity matrix times original matrix, that is x and y. Okay? When I calculate this one, negative 1 times 2 plus 1 times 3. Okay? 2 times 2 plus negative 1 times 3. Negative 2 plus 3, 4 minus 3. The solution is this one. Okay? If you remember, this 1 and 1 is the solution of this system of equations or the crossing of two lines. Okay? So that's why we use matrix theory. It solves the system of equations in a systematic way. Question? So, practice, practice, and practice. Then you will get something. Okay? So, if I do not give you some kind of examples, you will not do this kind of thing. So let me give you some homework for next 3 or 4 hours. Practice, practice, practice. After that, do some kind of solution, okay? Otherwise, I know that you guys will never solve this. Okay? Now this time our goal is, this is your homework, okay? Then the final question, the last question is x plus y equals 2 and 3x plus y equals 4. What I want you to do this is solve this system of equations by using matrix. Okay? That's what I taught up to now. Okay? Then this is your final homework. Please do this one. I think we will meet something like 4 p.m. today again.
This is final homework for today, right?
Yeah, for today. So you need to do this one right now. Practice and practice and practice. Then you can follow my afternoon class. If you don't do this today, in the afternoon class, you cannot follow this one, okay? So do this one. Then what you need is something called matrix multiplication. The first thing that you need to solve is something like this. 2 times 1, 2. This is question number 1. Okay? How do you do this? I think you know that. This one times this one, this one times this one, here and here. Okay? Practice it. Second one. 1, 2, 1, 2. This is 1 by 2 matrix. This is 2 by 1 matrix. What is the result? This one. Okay? Second, matrix multiplication. This is called as scalar multiplication of vectors. The third one, 1, 2, and 2, 1 this way. This is 2 by 1 matrix. This is 1 by 2 matrix. Okay? The result will be 2 by 2 matrix. Okay? This one times this one here. This one times this one times this one here. This one times this one here. This one times this one. Okay? Then the next step, 1, 2, 2, 1, 0, 1, 1, 2. 2 by 2, 2 by 2. Okay? You need to do this kind of multiplication. Then the fifth one is matrix inverse. What's the inverse of 1, 2, 3, 4? Inverse. Okay? Please use the theory AD minus BC, DA minus B minus C. Okay? If you are get used to this one, then the sixth question, write down this kind of thing in this way. 1, 2, 3, 1, 1, 1, 3, 1. X and Y
2, 4 equals 2.
2, 4. Calculate 1, 1, 3, 1 inverse. Okay? Then 1, 1, 3, 1 X and Y 1, 1, 3, 1 inverse 2 and 4. This one times this one will become identity matrix. Calculate this one by using matrix inverse. Okay? Then you can solve this question. Okay? If you done this one, I will give you one more homework. 2x plus y equals 3, x plus y equals 2. Different type of system of equations. Do the same thing with this one. Okay? Anyway, you can practice this one by changing these numbers. Okay? You will find out that if this number, this is called as determinant. When the determinant equals 0, you cannot solve this question because identity matrix do not exist. But when the determinant is non-zero, the solution is always existing. Okay? So when you make this kind of determinant equals 0, you cannot solve this one. Remember that? But when the determinant is non-zero, you can do this one for all the things. Okay? So practice this way. And when you're done with this one, okay? At the beginning of the next class, I will test it. Okay? And after that, I can proceed to the next step. This one is difficult, but not that extremely difficult. You guys can study together, solve it together, do whatever you want. But anyway, please understand this one until this afternoon class. Okay? I think I asked you to see you guys at 4 p.m. today. Okay? So see you guys at 4 p.m. But until then, please study. Okay, then I think I can stop today's class here.